The topic is basic properties of logarithms. The instruction says fill in the missing values to make the equations true. We see here three equations and we have to make the equation true, and that means that we need to fill in the spaces here, here and here in order to get to make these statements true. So let's start just coming back to the properties of logarithms. So the following properties hold for any base a. Remember that the base must be positive and different to 1. Then any positive numbers m and n. Anytime that you see these expressions in these letters in the expressions, it means that they represent positive numbers. And then at any number n, and this n is going to be the power. So here we have the first one, that is the logarithm of a product, and it means that when you have a logarithm of two expressions that are multiplying, we're going to write the logarithm with the first factor plus the same logarithm with the second factor. For the logarithm of a quotient, when you have a logarithm and the expression here, the argument also is known, is a quotient or a division, we're going to write this as the logarithm of the numerator minus the logarithm of the denominator. And the last property that I'm going to explain here is the power property. So when we have a logarithm and the expression here, the argument, has a base and a power, you can write this in this way. You take the power, and the power goes multiplying the logarithm. That is the thing that is happening here, and then you're going to get only the base for the argument. With this overview, I'm going to start with this expression that is logarithm base 7 of 9 minus the same logarithm base 7 of 8, and that must be equal to a logarithm base 7 of something. We need to find what would be the value here, or the expression, depends on the situation. So here I'm going to call that x, just to use a letter that represents the space that I need to fill in. And then we need to think, okay, we need to explore, we need to scan the expression. And the thing that we see here is that this is a difference, the difference of logarithms. And that means that we need to find a rule, a property that has that case. So this is the one that we know. The difference of these two logarithms is equal to the logarithm of the quotient. So we can write this in this way in order to see that we are going from the difference into the quotient. The difference of two logarithms are is equal to the logarithm of the quotient. So with that, we can go now into this. This 9 goes to the numerator and the 8 goes to the denominator. So at this point, we see that this logarithm and this logarithm, they are the same. So it means that this 9 over 8 must be equal to x in order to keep this equation true. So with that, we can say that this is the answer. This equation is true when we fill in the space with this 9 over 8. And the way to justify this is because of this property. Now let's see the second expression that is here, with the second equation. So we have the logarithm base 9 of 4 plus the logarithm base 9 of something that is missing here, and that is equal to the logarithm base 9 of 20. So I'm going to fill in the space with an x, and then we need to think here that we have an addition of two logarithms. So we need to find on the set of properties which one has this situation or this case, and we find that we have here the addition of two logarithms is equal to the logarithm of the product. So we can see also the same rule in this the same property in this way. So here we have an addition. Let me write that here. So that means that we're going to write this in this way. The logarithm base 9 of 4 times x, that is here. And at this point, this logarithm and this logarithm, they are the same. So we can write an equation only for saying that 4x must be equal to 20. Just taking this and this here. And then if we divide by 4, we're going to get the value of x. So x is going to be 20 divided by 4. So here we say that x is equal to 5. So now we can fill in the space with the proper situation. This addition is equal to the logarithm base 9 of 20. And this statement is true with this value of x equals to 5. Now let's see the last one, that is this one, and it's a logarithm base 6 of 25, and that is equal to 2 times the logarithm base 6 of something that is missing here. So now we need to see here that there is a coefficient number 2, and I'm going to fill the space with the x. Let me change the color of this into red. So the coefficient that we have here is 2. And we need to think, okay, what is the property that has this situation? And that property is this one. We see a coefficient, a number that is multiplying the logarithm. And then the thing that we see here is that this coefficient becomes the power of the number here. So we can write also the same property in this way in order to apply that here. And that is going to lead us to this expression. This number 2 becomes the power of x here. That is the thing that I am writing here. And then this logarithm is the same as this logarithm. So we may now go into that 25 is equal to x squared. It means that x has two options. Can be 5 or can be minus 5, but there is a restriction here that we have to take into account. This number cannot be negative, must be positive value. Remember the properties. So this is not accepted for to be the number of a logarithm. Let me write that here. To be the number of a logarithm and then we see that the number that was missing is 5. So we can write that now here. The number that was missing is 5. So that's all for this example.